Hello, hello to all my wonderful friends out there. How are we doing today? I hope that you're doing good. I hope that you're having a wonderful day. I am, so thanks. Today we are doing 6-3 in our notes, which is all about the properties of parallelograms. So last time we looked at the properties of kites and trapezoids, and today we're going to look at the properties of parallelograms. So we have 3 objectives today. So our first objective is to show that the consecutive angles of a parallelogram are supplementary and opposite angles are congruent, and we'll talk about that. We're going to show that the opposite sides of a parallelogram are congruent, and we're going to show that the diagonals of a parallelogram bisect each other. So remember, bisect means cut in half. Okay. But we do have new vocabulary. Our new vocabulary today is we're going to review what is a parallelogram. Okay, then we're going to talk about what does it mean if 2 angles are consecutive, and what does it mean if 2 angles are opposite. Then we're going to look at what are the properties of a parallelogram. So what makes a parallelogram different from a kite or a rectangle or a trapezoid or any other quadrilateral, okay? So we're going to jump down to the end, and we're going to go under our terms page, and we're going to find where it says parallelogram. Okay, so here we are under our terms page, and we're looking at parallelogram. Okay, and so the definition of a parallelogram, it's a quadrilateral, so it has 4 sides, and it has 2 pairs of parallel sides, meaning A and B are parallel to each other, let's say, and also A and D are parallel to each other. So opposite sides are parallel. Okay, opposite sides are parallel, so sides that are across from each other. And so you have to have not only A and B parallel, AB parallel to DC, but you also have to have AD parallel to BC. And that makes a parallelogram. Okay. In a parallelogram, and not just necessarily in a parallelogram, but just in general, consecutive angles are the same side interior angles of a quadrilateral. Again, quadrilateral, 4 sides. Okay, so consecutive angles right here. So they're angles that are next to each other. So this guy and this guy are consecutive angles. So they're angles that are next to each other. Okay, versus the other direction are opposite angles, which is angles that are across from each other. So here that would be like angle A and angle C. So the difference is angle here, A and B are next to each other, so they're consecutive. Here, A and C are across from each other, so they're opposite. So those are just the 2 different angles that we're going to look at inside of a parallelogram today. That's it for our terms. So the next thing we're going to do is we're going to go down to where it says the properties of special quadrilaterals. So we did kites and trapezoids in the last video. So today we're going to look at parallelograms. Okay, what are some properties of parallelograms? So we're going to start with looking at the angles of parallelograms here on the left, okay? Consecutive angles, and I'm going to try to do this in 2 different colors. We'll see how it goes, okay? Consecutive angles of a parallelogram are supplementary. Remember that supplementary means that they add to 180 degrees, okay? So this means that, for example, angle A and angle B, do you see how they are next to each other, right? So they add to 180, which it says right here, A plus B equals 180. Similarly, A and D are also consecutive. So A, right here, A plus D also equals 180. Okay. Now, in terms of consecutive angles, right, D and C are consecutive angles. They are next to each other. So D and C add to 180. And then lastly, B and C are also consecutive angles. So they add to 180. Okay. And then it says opposite angles are congruent. So B and D are the same. The measure of angle B and the measure of angle D are the same. And the measure of angle A and the measure of angle C are the same. Okay, so if you have a parallelogram, you only have two distinct angles, right? And those two distinct angles are going to add to 180 degrees. Now let's look at our sides and diagonals of a parallelogram. Okay, opposite sides of a parallelogram are congruent. That means that side AB and side CD are the same. And that's right here. AB is equal to CD. Also, then that means that AD is equal to BC, right? So that length is the same, which is written right here. So opposite sides are not only parallel, but they are also congruent. Okay, and then here, diagonals of a parallelogram bisect each other. Means it cuts the diagonals in half. So that tells me that B to X, right, the distance from B to X is also the same as the distance from D to X, which is right here. B to X and D to the X are the same. It cuts it in half. Also, that means that A to X, 2, 4, and C to X are also the same. Okay, and that's right here. So X is the midpoint of BD, and X is the midpoint of AC. So it cuts those lines in half. It does not say that BD is equal to AC. Okay, it does not say that. So the diagonals are not congruent. Okay, all I know is that where the diagonals cross each other, it splits my diagonals in half perfectly. So now that we've kind of reviewed the properties of parallelograms, we're going to go back and we're going to do our lesson, which is all about using these properties to solve problems. Okay, so here we are back at example 1, and we're going to go through this using those properties of parallelograms. So example 1 says, how do the lengths of the opposite side of a parallelogram compare to each other? Okay, so if we think back to what we just kind of wrote down, oh, that's a terrible parallelogram, the lengths of opposite sides are the same. Okay, so how do the lengths of opposite sides compare? We can say they are congruent. Okay, so the lengths across from each other are always the same. So using that information, I want you guys to try this one. What is the length of YZ? If you need to pause the video, go ahead and pause it. And let's figure out what the length of YZ is. So hopefully you guys tried this. Remembering that opposite sides are congruent, right? So YZ is right here. That is opposite of XW. These two sides are going to be the same length. So YZ is going to be 3.27. And we don't have the units there. Otherwise, of course, we would write them. So just keeping in mind that opposite sides are the same. Let's look at one that gets a little bit more complicated here, but the same idea. Okay, here I have quadrilateral PQRS, and I'm told that it is a parallelogram. So it tells me that my opposite sides are parallel and congruent. Okay, so opposite sides are parallel and congruent. Here it says, what is the value of X? Okay, so I know that opposite sides are equal to each other. So I can either take QP and set it equal to RS, or I can take QR and set it equal to PS. It doesn't matter which way you do it. I'm going to do it the two shorter ones. So I'm going to take my side QP and I'm going to set it equal to side RS. I can say that these are equal because opposite sides are equal. Okay, I'm going to subtract 5x. This gets me negative x equals negative 3. But I just want x, so I have to divide by negative 1. So I get x is equal to 3. And that's what it was asking me to find, right? What is the value of x? X is 3. Then it says, what is the length of each side? Okay, so we got to find the length of each side. So let's start with QR. QR is 7x minus 3, but I know x is 3. So 7 times 3 minus 3, which is 21, minus 3, which is 18 units. So that is the length of QR. If QR is 18 units, then I know that PS is also 18 units. I don't have to do the math on that because remember, opposite sides are equal. Okay? Now I'm going to do QP, which is 4x, but I know what x is, right? It's 3. So I get 12 units. So the length of QP is 12 units, which means that the length of RS is also 12 units. So hopefully that makes sense how we're getting those, just knowing that opposite sides are equal. Okay, we have a try it here, so I'm going to get rid of this and scroll down. Our try it here says, the 600-meter fence around City Park forms a parallelogram. The fence along Chaco Road is twice as long as the fence along Grover Lane. What is the length of the fence along Jones Road? Okay, so using the information in this problem, I want you to try to set this up. Remember, fill in what you know on your diagram if that helps. So go ahead and hit pause on the video and give this a try. Okay, so I hope you guys actually tried this and gave it a shot, and if you messed up, that's okay. We can erase it and try again. But I'm going to read this again. So the 600-meter fence, so I know that the total around the outside is 600. So 600 fence around City Park forms a parallelogram. The fence along Chaco Road is twice as long as the fence along Grover Lane. I don't know what the fence along Grover Lane is, so we can call that maybe X. But I know that Chaco Road is twice that, so that tells me that Chaco Road is 2 times X, which means Jones Road is also X and Village Drive is also 2X because, right, it's a parallelogram, so opposite sides are equal. Okay, and so I know if I add up all of 4 of these sides, it's going to equal 600. So that gives me X plus 2X plus X plus 2X equals that 600-meter fence. If I add this up, I get 6X equals 600. Divide by 6, divide by 6. X is 100 meters. So Grover Lane is 100 meters long, which means Jones Road is also 100 meters, which means Chaco Road is 200 meters, and Village Drive is also 200 meters. So the question then says, what is the length of the fence along Jones Road? Okay, so we can say Jones Road is 100 meters long. Or I guess we should say the fence along Jones Road. We don't know how long the actual road is, but we know that the fence along Jones Road is 100 meters. So hopefully that makes sense. That one was a little tricky because we weren't given any numbers except for the 600 meter. So we had to figure out if one side is X, the other side is 2X. All right, let's look at example 3. Example 3 says, And I'll scroll down a little bit so we can see that triad as well. Okay, so example 3 says, how are consecutive angles in a parallelogram related? So consecutive angles are the angles next to each other. Okay, so consecutive angles are supplementary. They are supplementary, meaning, right, that they add to 180. degrees. Okay, and then the second question says, how are opposite angles? So angles across from each other, how are those related? And those are congruent. So opposite angles are congruent. So we're going to use that information on this try it. You guys are going to hit pause on the video and try it, and you're going to find out what is the measure of angle A and what is the measure of angle C in this parallelogram. Then lastly, you are going to find what is the measure of angle B. Okay, so go ahead and hit pause on the video, and when you're ready to review it, hit play. Okay, so hopefully you tried it here. Let's review it. Angle A and angle D, I can call this X, add to 180. They are consecutive, meaning they're right next to each other, right? And so they add to 180. So X plus 114 equals 180. If I subtract 114 to both sides, I'm going to get X is equal to 66. So angle A here is 66 degrees. Well, if angle A is 66, so let's erase this and actually write it in, right? Write in what it is. Angle A is 66, then angle C is across from it, and opposite angles are congruent. So that tells me that angle C is also 66. So I don't have to do any extra work there. And then part B says, what is the measure of angle B? Well, B is opposite of D, and D is 114, so B is 114. So hopefully nothing too crazy there. You guys are going to try one more of this. So I'm going to erase, scroll down. You're going to do example 4 now. It's the same thing. Okay, I'm given that ABCD is a parallelogram. If the A is 62, what is B and what is C? So go ahead and hit pause, and then when you're ready to check your work, hit play. Okay, so here I would suggest always filling in what you know first. I am told that angle A is 62. Okay, and I want to know what is the measure of angle B. Well, A and B here are consecutive, right? They're next to each other. So that tells me that X plus 62 equals 180. If I subtract 62 to both sides, I'm going to get that X is 118. So the measure of angle B is 118 degrees. So once I figure that out, I can plug it in. Then it wants me to find what is the measure of angle C. Well, angle C is opposite of A, so they are congruent. So C is also 62. And that's it. Hopefully that's making sense, nothing too crazy. If you need help, make sure that you reach out and ask for it. All right, let's look at example 5. So example 5 says, and I know you can't really tell if it's green on your paper, but hopefully, at least with the video, you can tell where it's green, right? The green shape in the fabric design is a parallelogram. The measure of angle 2 is twice the measure of angle 1. Okay, so what is the measure of 1, 2, and 3? Okay, so I don't know what angle 1 is, so I can call it X, but I know that angle 2 is twice it. So angle 2 is 2X. Since it's a parallelogram, I know that this is X, and I can also say that this is 2X. Okay, this is a 4-sided shape. So going all the way back to 6-1, the sum of all of the interior angles, so all of these angles added up, will be 360 degrees. because this is a four-sided figure. So I can set up an equation now. X plus 2x plus x plus 2x, right, equals 360. So when I add it together, I get 6x equals 360 divided by 6 divided by 6, and get x equals 60. Okay, so now if I kind of like erase this because it's hard to see, x is the measure of angle 1. So the measure of angle 1 is 60 degrees, which means that the measure of angle 2 is 2 times x, so 2 times 60, which is 120. And then the measure of angle 3 is opposite of 2, so that will also be 120. And there is no angle 4, so I don't have to worry about this other one. But if I did, it would also be 60 degrees because it is opposite of 1. Okay, hopefully that makes sense. We just have to read the problem really carefully and make sure that we know the properties of our parallelogram. We have a try it here for you guys. Here it says use the parallelogram shown. So again, I know it's a parallelogram. So given this parallelogram, what is the value of A? Okay, notice that I'm given that these two angles, one angle is x plus 5 and the other angle is 8. Wow, that's an A. Sorry, A plus 5. The other angle is 8A minus 5. What do I know about these two angles if they are consecutive, right? They should add to 180. So go ahead and pause the video, see if you can find the value of A. Once you've found the value of A, see if you can find what is the measure of angle G, H, J, and K. Okay, so hopefully we gave this a try. When we go back and we think, what do my consecutive angles do? What's the property of consecutive angles in a parallelogram? And what it is they add to 180, right? So if I add one angle, which is A plus 5, plus the other angle, which is 8A minus 5, I should get 180 degrees. So let's solve this. A plus 8A is 9A. 5 minus 5 is 0. I get 180 divided by 9, divided by 9. And I get A equals 20, which is what it's asking me to find in that first part. Now in the second part, it says, what is the measure of angle G? So we can just start there. Angle G is 8A minus 5, right? So it is 8 times 20 minus 5. 8 times 20 is 160 minus 5. So I get 155. So the measure of angle G is 155. Then it wants the measure of angle H. Angle H is A plus 5. Well, I know what A is. It's 20. So I have 20 plus 5, which equals 25 degrees. Okay, so G is 155, H is 25. So then when I go in to do J, J is across from G. So if G is 155, J is also 155. And then same thing for the measure of angle K. K is across from H. So if H is 25, K is 25. So really we only have to calculate for the first two. And then we know that the other two across from those are just going to be congruent. So again, if you have any questions on this, make sure that you guys reach out. The last thing that we're going to do today is we're going to talk about the diagonals of a parallelogram. So let's go down to example 6 here. Okay, so example 6 says, how are the diagonals of a parallelogram related? AC, A to C, and B to D are the diagonals of parallelogram ABCD. Okay, so they're the diagonals. So here we have a proof. Woohoo! I know you guys just love proofs so much. So I'm really excited that we can do this for you. That was sarcasm, okay? I'm given that ABCD is a parallelogram, and I want to prove that A to Q is equal to C to Q. And I want to prove that B to Q is equal to D to Q. So I have a lot of work ahead of me. But the first thing I have to do is make my columns. Remember that the left side of my columns are always my statements, and then the right side of my columns are always my reasons. Okay, so the first thing you always do is you write down what was given. So we say A, B, C, D is a parallelogram. So there's my statement. Then the question is, why can I say that? How do I know that, right? And that was given, so that's going to be my reason. It was given to me. I was told that. So that's kind of the first piece there. Okay, so because ABCD is a parallelogram, I can say, right, that AB, side AB, is parallel to side DC, or CD, either way. This side is parallel to this side. And then the reason, why can I say that? How do I know that those two sides are parallel? Well, in a parallelogram, opposite sides are parallel, right? So this is the definition of parallelogram. By definition, I know that opposite sides are parallel. Okay. So draw. Okay, so I'm trying to prove, right, these diagonals. So, and then I also have these angles that are written in. So let's see if that's going to be helpful at all for us. I can say that angle 1 is congruent to angle 4. All right, so these two, angle 1 and angle 4, are the same. And I can also say that angle 2 is congruent to angle 3. And I can say both of those things because of alternate interior angles. Remember, one's on one side of the transversal, one's on the other side of the transversal, and they're both inside the parallelogram. So this is alternate interior angles. Okay, so I'm going to draw that in then as well. Cool. So this angle and this angle are the same. And then this angle and this angle are the same. Okie doke. So I know that these two angles are the same, so that's exciting, okay? Since this is a parallelogram, not only are sides A, B, and DC parallel, but they are also congruent, right? And I know that, again, because a parallelogram, opposite sides are congruent. So I can also say that AB is congruent to CD. And again, that's the definition of parallelogram. Those opposite sides are the same. So if those opposite sides are the same, I'm going to draw these two triangles separate here. So here's, this is B, A, and Q. So there's one of those triangles. And then here's the other one, where this is D, C, and Q. Okay, so I know that BA and DC are the same. I know that B and D are the same. And I know that A and C are the same. So just looking at these two triangles separately, would I be able to say that these two triangles are the same? And hopefully we realize that yes, we can, right? When we think back to what we've done before, I have angle, side, angle on both of these. So I can say that triangle ABQ is congruent to triangle CDQ by angle, side, angle congruency. Okay, so if these triangles are the same, so let's think about this. These two triangles are exactly the same. I've just proved that, right? So if these two triangles are the same, is BQ and DQ, are they the same? Yeah, because the triangles are the same, right? So now I can say that BQ is congruent to DQ because those triangles are the same. And I can also say that AQ is congruent to CQ. So AQ is congruent to CQ because the triangles are the same. Okay, and look, that's what I was trying to prove. I was trying to prove that this and this were the same and that this and this were the same, which I just did. Okay, the reason I can say that those are the same, you have to think back, is because congruent parts of congruent triangles are congruent. Okay, so once I prove that the triangles are the same, then I can say that any part of those triangles are the same. So that's proving why. Okay, so we have proved why the diagonals bisect each other. So what we're going to do now is we're just going to practice it, okay? We know that the diagonals are cut in half. So let's use that information to solve problems. So just to show you here, let's do the first one together and then you guys can try the second one. Actually, let's do the second one together and then you guys can try the first one. I like that one, but I like that better. Okay, so we're going to do this one together. So here it says if AE is 4, AE is 4, so I'm just going to label it. BE is 2. What is AC and what is BD? Okay, so I'm going to erase this 2 and let's just start with the first one, okay? So if A to E is 4, then that means C to E is also 4. So the total distance here should be 8. So the diagonal AC is 8. Similarly, if BE is 2, right, and and that means, sorry, it's cut in half, so that BE is 2, that means that DE is also 2. So then what's the whole distance BD? Right, should be 4. So it's just using this fact to help us solve problems. Okay, so hopefully nothing too crazy here. The last one is one I want you to try on your own. So you're going to hit pause on the video and give this a shot. When you are ready to ready to go over it, hit play on the video and then we'll review it together. Okay, so let's review this last problem. It says use the parallelogram RSTU with STU, so this whole thing is 35. And K to T is 19. Okay, so I'm going to go through and I'm going to I guess let's look and see what they want. They want what is SK, so this is what they're looking for here. SK is half of the total distance because in a parallelogram, the diagonals are bisected. They are cut in half. So half of 35, right? So SK equals half of 35, which is 17.5. So that means this is 17.5 and this is 17.5. Okay. Then part B says, what is RT? So I know that K to T is 19, which means R to K is also 19. So what is the total distance? Well, 19 plus 19 gives me my full length of 38. And that's it. We're just using the property that the diagonals bisect each other. All right, guys, so that's it for section 6.3. If you have any questions, make sure you reach out, and we'll see you on next video.